Hello. Was a really nice couple of talks. But it's time for the next one. So I would like to invite now Ram to the stage. Hello, Ram. How are you
Hey
doing?
Christian, I'm doing fine. How about yourself?
I am sleeping already. That's why I'm wearing glasses because it's too early
Yep,
here
I
on
can
this
tell.
side of the world. But I am really looking forward to your talk. It's a really tricky topic in Python. I mean, packaging applications and everything is something that every Pythonista knows that it can be a little bit tricky. So I can see your
Mhm.
slide already. I will not take more of your time. So the floor is yours. Good luck.
Thank you very much. Hello, everyone. I hope you had a wonderful time so far at Pajamas. Before I even begin, big thanks to all of the organizers for having me. And I just would like to share some stories about an open source tool chain that the community that I manage and I'm a part of is basically creating and maintaining in order to package and help deploy Python containers. A brief introduction. My name is Ram. I am the chief evangelist at the Cloud Foundry Foundation. For those of you who might not know what this is, so it's a governing body. We are a directed fund under the Linux Foundation, and we basically oversee a lot of the management and governance around the Cloud Foundry project. And in addition to that, we have like a bunch of other projects that are in the Cloud Foundry ecosystem. For example, Paketo, and we have Open Service Broker and a few other CI/CD tools, so on and so forth. My job there is to basically build awareness of some of the tools that we build as a community, and also basically make folks aware of what the tools are, how best to make use of them, and how best to work with them. Today we're going to dive deeply into a particular tool. They're commonly known as build packs, and anybody who has used Heroku in the past are probably aware of build packs. And they were started in the year 2011, so that's like a little over 10 years ago, which is like 1,000 years in computer kind. But it basically started a decade ago as a means and way to package applications in order to prepare them for deployment. So the goal of a build pack was to detect the language in which the source code that is supplied to it is written in, assign the right kind of build packs, or the tools that will build it, and then create an immutable artifact out of the source that can then be deployed to any infrastructure of choice. Now, along the way, build packs sort of diverged into two. So there was the original Cloud Foundry Heroku version, and then there was a forked, what was known as Pivotal back then, but was essentially a Cloud Foundry version of the build packs. About 4 to 5 years ago, these communities converged once again in the light of Kubernetes becoming very dominant, in the light of cloud native technologies becoming very dominant. These two communities decided to converge once again and focus all of their efforts on creating what are known as the cloud native build packs. Um, I'll quickly show you the website too. So buildpacks.io is the website for cloud native build packs. So this is a project that is owned by the CNCF, the Cloud Native Computing Foundation, and they basically provide the spec for what the build packs are. And then using this spec, we basically derive the other build packs, and those build packs allow you to package your application and things like that. Cloud native build packs are essentially, like I said, a specification, and one of their chief sort of claims to fame is that they help avoid Docker files, among other things. Now, it's reasonable to assume that when your developers are already doing like 18 things right now in order to build the application, containerize it, and put it on production. Writing and maintaining Docker files can be a little bit of a cognitive overhead. It's a technology by itself, and it's kind of not fair, I guess, to expect developers to know an additional technology just in order to containerize it. Now, build packs were created with the idea that builds should be reproducible, they should be optimal, and they should just work. I mean, without having any application developers or application development teams rewrite a lot of the stuff that is required in order to do the build. The builds should just be able to work and work efficiently. So that's the goal with which build packs were created. And today, we are going to talk about a specific implementation of the build pack spec known as Paketo. Now, Paketo is an open source project. It is, like I said, it is owned by the Cloud Foundry Foundation. A big chunk of maintainers for this come from Heroku and VMware and like a whole bunch of different places. SAP has also demonstrated considerable interest in the Paketo Buildpacks project, and we're seeing a lot of different teams adopt Buildpacks for their build infrastructures and build pipelines. Um, I'll get into some details about who they are and what is on the inside and stuff like that. But before we do, the fundamental idea that Paketo build packs and build packs in general preserve is build packs should work irrespective of what language or framework is being put to use. So it presents a uniform and homogeneous interface irrespective of what source you provided. That being said, if your web application is composed of like many different languages or language families or framework, as it should be in this era of microservices, it is also possible to make use of build packs to build apps that are written that way and deploy them basically. A deployment is obviously um, something slightly outside the context of the Paketo build itself, but we'll take a look at all of these different things shortly. And the reason I named this ship more scriptless is basically because of a lot of the cognitive overhead that it removes, and second, a lot of the actual effort that developers have to do in order to make use of these build packs itself are eliminated. So let's take a look very quickly at what a demo looks like. So what I'm going to do is I'm going to clone a repo. That's basically a Python repo from somewhere. Let's see. um, Sorry. So there's probably like a hello world in here somewhere there. Um, yeah, so very simple hello world Python Flask application. So let me quickly clone this. Yep, so that's empty. So we clone that. Okay, so it's organized like this. So I'm going to put the app. Okay, so here's like I think a very basic Python application, and then this. What I'm going to do additionally is to just create what is known as a proc file. And a proc file is basically going to tell um, the app what the start command is. So let's see, just to make sure. Yeah, so the start command for this is looks like that. So let's copy that into what is known as a proc file. And I'll copy this from one of the samples that I have. Oh, and then let's see. So instead of this command, basically say, I hope that's right. It's got to be this app main.py. Okay. Okay, so hopefully this works. Let's see. So my command for building this is going to be pack. So pack is a CLI that you can find in Cloud Native Buildpacks. It's built by the Cloud Native Buildpacks. It's on their website. So this is the CLI that I'm going to be using. So it's a tool that is basically used to manage the entire life cycle of the build packs and the build process itself. So the command that we are going to use is pack build, and then I'm going to give the image a name. So in this case, like nothing too creative. And then one of the, or you can provide it two parameters. You can specify a build pack, but I'm not going to do that. But then what it expects is you need to show or tell this one what the builder is. So in this case, I'm going to make use of a Paketo Buildpacks, and I'll quickly show you what the list is. Pack builders suggest. Yeah. So basically, Pack has a bunch of builders, and builders are basically build images that we are used to seeing in the outside world. So Google, Heroku, and Paketo are like the three available sort of build images, and then we can make use of different build images in order to actually build the app. So that's the one that I'm going to be using, and let's kick off a build. Missing something obviously. Pack build. Builder. Here. Okay. So then, just like any container build process, this is going to go ahead and download like the whole internet for us before building the container. And so this basically kicks off a process where it composes the web application into several layers, and then it's able to get the OS layers, the libraries, and all of the other dependencies. And what's interesting to me as a consumer, obviously, too, is I don't have to specify what language or what framework the app actually is in. So this is the exact same experience you would get if you were building any other app. Like it could be Node.js, it could be Java, it could be whatever. But although this community doesn't really care about that, so it'll detect your language. It will then read into what kind of dependency management is in use here, and then it will apply that build process appropriately. So I'll just quickly switch to some slides here while we talk about that, and I'll come to this a little more. So basically, that's what I was talking about. Any image is composed of like apps and dependencies all the way down to the OS, and basically once you create these layers and create the container, you're able to deploy them to a container runtime. Now If you have source code and a Docker file, obviously you're building a Docker image. But in this case, you're still building an OCI compatible, an open container image compatible image, but you're doing that with the pack CLI. And so um, one of the pieces that's here is the Paketo builder, like I showed, and then all of the other stuff is made use of with the app itself. And so this is the demonstration that we have going right now. So there is a Python app, there are the Paketo build packs that are going to be in play, and these are all invoked by the pack CLI in order to output an OCI compatible image that has the app, that has the language runtime, that has the library, and all of the other dependencies. Um, It's taking a bit of time, but I think we'll get there. So let's continue to watch this demo. Um, but I'll speak to some of the things that are going on here. So Paketo is capable of creating these app images irrespective of what container libraries that you make use of. Um, Sorry, whatever dependency management tools that you make use of. So seeing a lot of progress here, which is good. So you could use any of like the popular um, dependency management, but it will still function like fully well. um, and then especially for like Python devs, where I've seen a lot of difficulties mentioned about containerizing Python applications, Paketo works in order to sort of eliminate all of those difficulties that arise from the whole containerization process. So there's no need to have separate builds for like local and staging and production and things like that. So Paketo is fully capable of creating a uniform, homogeneous, repeatable build process that works not just locally, but it will function the exact same way on any remote staging instance that you want to use this on, including production. And so that, again, in my opinion, is like a huge win, not just as somebody who showcases this, but also as somebody who makes use or consumes this technology. And so after all of the downloads have begun, let's just switch to this very quickly. So because there's no previous image with the same name that was found, um, the build packs will start to list all of the different build packs itself that will participate in this. And so we have C Python that's going to get kicked in. We're going to have pip that's going to get kicked in, and we are at the end of the build. So as we were talking through that, the rather long sort of build process completed. So let's see, I'm going to run this locally on a Docker runtime that I have. Sorry. Yeah, so there's nothing there. And so let's do a Docker run. Let's see if this works. Okay. Let's see. I'm going to delete this. I'm going to pack build this again. Second time this will be much faster, hopefully. Yep. So you can see how fast that process is because of all of the caching that it has. So this is again one of the advantages of using Paketo, but let me try and run this. Yes. So now we have an app going. Um, Yay. So we've containerized this application. It's running. It's fully functional, right? So again, I have not seen this app before, and I didn't make use of the Docker file. You didn't have to like do any additional configuration and things like that in order to build it. And Paketo again is able to detect the language, apply all of the dependencies that are required, and get everything going in order to make the app actually fully functional. So again, we did get a chance to demo um, how quickly the app is able to manage changes. Let's see now. I'm going to alter a few things here and see how quickly it functions now. Build using Paketo shown at. So I'm going to alter the code and we're going to see how quickly it's going to work again. So pack build, same container name, obviously. Um, I'm just going to run that. And again, it's very fast, largely because obviously the app is small too, but also because it's capable of that kind of caching and other things. Now, yeah, the app has updated. You can see that, and it's basically showing like the new stuff. There are Paketo samples that you can make use of. So I'm going to so you can make use of different package managers and see what the container will look like. It's You're going to be able to make use of any container management I'm sorry, dependency management tool of your choice when using Python, and the the build experience will look exactly the same. So Paketo is fully capable of detecting which of the different package managers you're using and load your dependencies that way. So yeah, that's a big part of the demo. We're kind of running out of time. I'll showcase one or two other things very quickly that will really demonstrate how you can make use of. So one of the things you can do is load the image in for deployment into like a local kind cluster. I don't have one running. Sorry, I should have set that up. And then one of the other things that we can also do is download SBOMs. So SBOMs are like a big deal right now, largely because open source software supply chain security is very important. Paketo has a default way in which it creates SBOMs. So if I switch to this directory, you will see that it has like very detailed SBOMs that are created, and these SBOMs are they're all organized depending on all of the different build packs that participate. So both CPython and pip install have participated in the build of this container, and so it contains all of the data there. And one of the things that I also like about this is it creates the SBOMs in all the different formats that are required. So Cyclone DX, SPDX, and SIFT are like the major formats for SBOMs today. And Paketo creates that for you by default. So these are some of like the additional benefits of using Paketo. But even without all of these frills, I think it's a great technology for the Python community to have and make use of in order to create containers and make use of those containers wherever. Right. So a lot of benefits that you can derive in order to containerize your apps and ship them without having to get into a lot of the heavy duty scripting and other things that are involved. And so that's why I decided to name the talk Ship More and Script Less with Paketo Buildpacks. Thank you for listening in today. Thank you to all of the organizers for making the talk possible. Hopefully, I'm able to return in a future edition of this conference. But thank you very much.
Thank you very much, Ram. Uh, really interesting topic. I have many friends that are really into Docker and everything, and yeah, I do hear time to time that they lost a lot of time complaining about scripting too much. And this sounds like I was not aware of Paquito, so it was really cool. Nice. So we don't have questions at the moment. It will be maybe really convenient if you can share on Discord maybe some links or something
Sure.
to try to get to some demos and stuff like that. And
Mhm.
yeah, just thank you again for your participation and wish you a nice Sunday.
Yeah, thanks, Christian. Thanks for having me.